All right, welcome everyone to the deep dive. Today we're going deep on something that's, well, kind of a silent partner in how the web works. You bump into these things all the time online, whether you realize it or not. HTTP cookies.
Yeah, you got it. And we've got this super insightful guide here to help us break it down. It's called Understanding HTTP Cookies, a Developer's Implementation Guide by Nick Webson over at Rebrowser.
And the cool thing, it's brand new, practically just came out a couple of months ago.
Right on.
So what we really want to do in this deep dive is, I think, get to the bottom of what these little bits of data actually are.
Absolutely.
Why are they so important to how we experience the web? The stuff we totally take for granted, staying logged in, having our preferences remembered, even how websites personalize what we see. We're going to trace their history, how they actually function, dive into the crucial security side of things, and even peek into what the future might hold for them.
Sounds good.
Okay, so HTTP cookies. You hear about them constantly, especially with all these consent pop-ups these days. But at the most basic level, what problem did they even solve? What's their main gig?
That's a really great place to start. Think of it like this. HTTP, the fundamental language of the web, it's kind of like a waiter with a really, really bad memory.
Okay.
Every single time you ask for something, like a web page, a picture, whatever, it's like starting from scratch. The server, by itself, it has no clue who you are or what you were just looking at a second ago.
So every time I click a link, it's like reintroducing myself to the website. Hi, nice to meet you again.
Exactly. Now imagine trying to shop online, filling up a cart. If the website forgot everything you added after every single click, chaos.
Oh, for sure.
That's where cookies step in. Like Nick Webson explains in this guide. They're these tiny text files. Think of them like little digital sticky notes, no bigger than 4 kilobytes. And they allow websites to keep a memory of you, which is what we call a session. And they have a few main jobs. Keeping you logged in as you browse the site, that's session management. Remembering your preferences, like the language you want, or display settings, which is personalization. And yeah, let's be honest, tracking what you do on the site for things like analytics.
Got it. So when I log into a website once and then I can just hop around different pages without logging in again and again, that's cookies working behind the scenes, right?
Exactly. And the process, when you break it down, it's pretty simple, actually. You land on a website for the first time, and the server might send back a special instruction in its response. It's called a set cookie header. And this header, it contains the actual cookie data. So your browser sees that, grabs that little piece of info, and stores it away. And then from that point on, every time your browser goes back to that same website, it automatically attaches that cookie to the request it sends to the server.
So it's like my browser flashing a backstage pass to the server every time it needs something.
That's a perfect way to put it.
Okay.
It's also important to remember that these backstage passes, they're usually specific to the website that gave them to you. So a cookie from, say, Rebrowser.net, it can't be read by a totally different site like example.com.
Right. Makes sense.
But here's a little twist. The guide points out that websites can be set up. So cookies from the main domain, like Rebrowser.net in this case, can also be used by its subdomains, like, let's say, blog.rebrowser.net.
Yeah.
And that can make moving around bigger websites a whole lot smoother.
Makes sense. So these tiny files have been around for a while, right?
Yeah.
I mean, the guide mentions 1994 and a name that rings a bell from the early days of the internet, Lou Montulli, over at Netscape.
That's right. It's kind of wild to think something invented way back then is still running the show today.
Yeah, and that's nuts.
And you know what? The original problem he was trying to solve was surprisingly specific. How to make online shopping carts actually work.
Oh, interesting.
Because how do you keep track of what someone's adding to their cart when they're clicking all over the place, adding different products? Cookies were the answer. They were that initial elegant solution. And it's pretty incredible to think that such a seemingly simple fix, it really laid the foundation for this whole personalized web experience we have today.
Oh, absolutely. So from cracking the code on the very first e-commerce websites to basically powering everything online today. And this guide, it lists out all these expanded uses, managing sessions, storing our preferences, analytics, even those targeted ads that seem to follow us everywhere. And to think it all comes back to this tiny text file, no bigger than 4 kilobytes. Wild.
It really is.
Yeah.
And as the web got more complex, so did the ways we used cookies. And that kind of brings us to the different types of cookies and how we categorize them.
Right. The guide breaks them down by how long they last and where they come from.
Exactly.
So let's start with duration.
Yeah.
Session cookies versus persistent cookies. For us as everyday users, what's the main difference?
All right, so session cookies are like the website's short-term memory,
Yeah.
just for that visit. They're temporary.
Okay.
As soon as you close your browser window, poof,
Gone.
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 Really helpful for things like remembering what's in your online shopping cart as you browse, or keeping track of your progress when you're filling out one of those long multi-page forms.
Right. So they're just for that immediate visit tied to when I have the browser open.
Exactly.
Then we've got persistent cookies. These are the long haulers, right?
That's right. Persistent cookies, they hang out on your device until they hit their expiration date. That's something set by the website's server. Or until you decide to go into your browser settings and manually delete them. These are often what's behind those Remember Me features on login pages, or they might be storing your website preferences, like your preferred language.
Sure.
Or if you like dark mode, that way the site's all set up just how you like it when you come back.
Gotcha. So session cookies for the here and now and persistent cookies for a more personalized experience over time. Makes total sense.
Makes sense.
Now let's talk origins. First-party versus third-party cookies. This is where the whole privacy discussion really heats up, right?
Oh, absolutely. First-party cookies are set by the website you're directly visiting. That's the domain name you see right up there in your browser's address bar.
Yeah.
These are generally considered less risky since they're coming straight from the site you've chosen to be on.
Okay.
And they're often essential for the website to even function properly.
So if I head to Rebrowser.net and it sets a cookie to remember that I'm logged in, that's a first-party cookie.
You got it. Now, third-party cookies, that's a whole other story. These come from a different domain, not the one you're actually on at that moment. This usually happens when websites embed content from external places like ad networks or analytics providers. And since these cookies can potentially follow you around, tracking what you do across different websites, they've become a big privacy concern. And browsers and privacy laws are getting a lot stricter about how they're used. They're the ones that can give you that feeling that those ads for that thing you looked at once are like haunting your every move online.
Yep. Definitely know that feeling.
Definitely.
The guide dives into how cookies are actually implemented these days, and security is, as it should be, front and center.
For sure.
They mention the set cookie header and give an example. Session ABC 123 expires WED 24 December 2024 23.59.59 GMT. Path domain rebrowser.net, secure, HTTP only, same site strict. Okay, that's like a whole lot of code.
It is.
Let's unpack the last three parts of that. Secure, HTTP only, and same site. What are those actually doing to keep us safer?
All right. So secure, that's all about protecting your data when it's on the move. When a cookie has that secure flag, it means it's only going to travel over a HTTPS connection, one that's encrypted. It's kind of like sending that cookie data in a locked box, and only the right key can open it. This is super important for stopping eavesdroppers, preventing what are called man-in-the-middle attacks. That's where somebody tries to sneak in and intercept your internet traffic, maybe steal your cookies. If you're handling any kind of sensitive information, the secure flag is non-negotiable.
So secure basically means it needs that HTTPS protection, the encrypted connection.
Exactly.
What about HTTP only? That sounds like it's putting limits on what can actually access the cookie.
You got it. The HTTP only flag, that's like a bodyguard for your cookie. It tells the browser, hey, don't let any client-side scripts mess with this. And the most common type of script is JavaScript. This is a major defense against cross-site scripting or XSS attacks.
Oh, okay.
Imagine for a second some bad code gets injected into a website you're visiting.
Okay.
If the cookie has the HTTP only flag, that malicious script, it can't read it, it can't change it, nothing.
Oh, that's good.
And this is especially crucial for cookies that are holding things like session IDs or authentication tokens. Those are the keys that keep you logged in.
Okay. Yeah, that makes sense. That's huge protection against a pretty common online threat. Now we've got same site. This one seems to be making headlines a lot lately. What's the story with same site?
Same site, it's all about preventing something called cross-site request forgery. We usually just call it CSRF.
Okay.
It basically controls when your browser is allowed to send a specific cookie along with requests that are coming from a different website.
Got it.
And there are a few different settings for same site: strict, lax, and none. The guide's example uses strict, which is the toughest one.
Okay.
It means that cookie is only going to be sent if the request is coming from the exact same website that set the cookie in the first place.
Right.
Then there's lax. It's a bit more relaxed.
Yeah.
It lets the cookie go along with top-level GT requests from other sites, which is useful for things like clicking on a link. And then there's none. It basically says the cookie can be sent in all cross-site requests, but with a big caveat. It also requires the secure attribute to be set as well.
So choosing the right same-site setting, it's kind of like walking a tightrope, right?
Yeah, you could say that.
You're trying to boost security, but also make sure that different parts of the web can still talk to each other when they need to. I imagine developers have to really think through the cross-origin needs of their applications, right?
You're absolutely right. Like, if you've got an embedded video player on your site that's coming from a different domain, you need to consider how same site is going to affect how that player works.
Right.
The guide really emphasizes that developers need to think carefully about the implications of each of these security attributes when they're setting up cookies, especially when it comes to authentication. They even give a practical example of how you'd configure these secure cookie settings in a framework called express.js, a pretty popular one.
Yeah, for sure.
They show you how to set secure, true, HTTP only .true,
Yeah.
and same site strict, and how to specify how long the cookie should hang around. It's a nice concrete look at putting these best practices into action.
Absolutely. Let's dig into those security considerations a little deeper.
Sure.
The guide lists some common ways that attackers might try to snatch those cookies. We've already touched on XSS, where they slip in bad scripts to try and steal them,
Right.
and CSRF, where they try to trick your browser into doing stuff you didn't authorize. And then there's man-in-the-middle attacks. The secure flag helps with that, doesn't it?
Yes, the secure flag is your first line of defense against man-in-the-middle attacks.
Okay.
It makes sure the cookie data is only sent over HTTPS, that encrypted connection.
Okay.
But it's super important to remember that that secure connection, it only protects the cookie while it's in transit. XSS and CSRF, they exploit different vulnerabilities.
Okay.
XSS, that's focused on the client side, trying to steal the cookie right from your browser.
Okay.
While CSRF, it's more about tricking your browser into doing things it shouldn't on a site where you're already logged in. So it's really about layering your security, using different tools to guard against different types of threats.
Got it. So cookies are super useful, but they do come with these built-in security considerations that developers need to be super careful about. The guide also mentions some of the more modern ways of handling data in the browser and for authentication, like alternative to cookies and things that work alongside them. One of those is the web storage API with local storage and session storage.
Yeah.
How do those compare to our good old cookies?
So the web storage API, it gives developers a much more powerful and flexible way to store data directly in the user's browser.
Okay.
Both local storage and session storage. They let you store way more information than a cookie's tiny 4 kilobyte limit.
Ah.
Plus, and this is a biggie for performance, the data stored using web storage, it doesn't get sent with every single HTTP request, which can really speed things up.
So it cuts down on all that back and forth traffic.
Exactly.
So what's the difference between local storage and session storage then? When would you choose one over the other?
The main difference is all about how long the data sticks around.
Okay.
With local storage, the data is persistent. It stays put even after you close your browser window and reopen it later. It doesn't have an automatic expiration date unless the website's code specifically removes it.
Okay.
This makes it a good fit for things like user preferences that you want to remember across multiple visits. Just like the guide mentions, it could be used to store someone's preferred website theme or language.
Okay, so it's long-term storage right there in the browser. And session storage, that sounds more temporary.
You got it. Session storage is like a short-term memory that's tied to a single browser tab or window.
Okay.
The data you put in there, it only lasts as long as that tab or window is open. Once you close it, boom, the data's gone. This is really handy for temporary data, stuff that's only needed for that specific interaction you're having with the website at that moment. The guide uses the example of storing temporary form data as you're moving through different steps.
Gotcha. So web storage gives you more space and more control over when that data gets sent.
Exactly.
The guide also brings up JSON Web Tokens, JWTs.
Right.
How do those fit into this whole world of user sessions and authentication?
JWTs, they're a different way of verifying who a user is.
Okay.
And they often work hand in hand with cookies.
Okay.
See, unlike traditional session-based authentication where the server keeps track of who's logged in, JWTs are what we call stateless.
Okay.
So when you log in, the server creates a JWT, which is like a digital ID card that's been digitally signed, and it contains information about you.
Okay.
This token is then usually stored on your computer, often in a cookie, hopefully with those security slides that we talked about, or sometimes in web storage.
Okay.
And then every time you make a request to the server, your browser sends that JWT along with it to prove it's really you.
So instead of the server having to constantly check this big list of who's logged in, the JWT itself has all the info it needs.
Precisely. The server can quickly verify that the JWT is authentic and hasn't been tampered with, all without needing to constantly check a database.
Makes sense.
The guide even links to another great resource from Rebrowser that goes deeper into using JWTs with HTTP headers and a tool called Axios, if you're interested in that.
Cool. It sounds like JWTs are a more modern way of handling authentication, and cookies are still a good, secure spot to keep those tokens. Now, with all this talk about data and how it's managed, we have to address the elephant in the room, the rules.
Absolutely.
The guide specifically mentions GDPR.
Yeah.
What are the big things we need to know about cookies and GDPR?
GDPR, the General Data Protection Regulation in Europe, has been a real game changer for how websites use cookies. The guide highlights a few key requirements. First up, and this is the big one that's led to all those cookie consent pop-ups we see everywhere, is the need for explicit user consent for any cookies that aren't absolutely essential for the website to work.
Okay.
You can't just drop tracking cookies on someone without them actively saying, yep, that's okay.
Right, that's why every website I go to seems to ask me if I accept cookies.
Exactly. Second, websites have to have a clear, easy-to-understand privacy policy.
Okay.
It needs to spell out exactly how they're using cookies, what data they're collecting, and what they're using that data for. Transparency is key.
Makes sense.
And lastly, users have to have a clear and straightforward way to withdraw their consent, if they change their mind.
Right, so it's all about being upfront with users and putting them in control of their data.
Precisely.
And the guide actually gives a simple example of how a cookie consent banner could work.
It does.
It has functions like show to display the banner, accept to record consent, and reject to say no thanks. I imagine that would then set a cookie, maybe called cookie consent, to remember what the user decided.
Right. That's a really basic illustration of how consent management works.
Okay.
But out in the real world, it gets more complicated.
Okay.
You might need to categorize different types of cookies and give users more fine-grained control over what they're comfortable with.
Got it. Let's shift gears a little and talk about something that directly impacts how fast a website loads performance.
Sure.
The guide mentions that having really large cookies can actually slow things down. Why is that?
So cookies are sent along with every single HTTP request that your browser makes to the website that set them.
Okay.
That means every request for every little thing that makes up a web page, images, styling files, CSS, even the code that makes things interactive, JavaScript. If your cookies are loaded up with a bunch of unnecessary data, it's like adding extra weight to each of these requests.
Yeah.
It eats up bandwidth and increases the time it takes for the page to load. And that's especially noticeable if you're on a slower connection or using a mobile device.
Makes perfect sense. All that extra info going back and forth all the time can really bog things down. So what are some ways, according to the guide, that we can keep our cookies lean and efficient?
Well, the guide mentions a few good strategies. The most important one is keeping the overall size of your cookies under that 4 kilobyte limit. Using appropriate expiration dates, so cookies aren't hanging around longer than they're needed. That's another good one. And of course, regularly checking and deleting any cookies that are no longer being used.
Okay.
One clever trick is to use entirely separate cookie-free domains for serving static assets like images and CSS files.
Ah, interesting.
Since these files usually don't need any user-specific information, you can avoid sending cookies with those requests altogether.
Oh, that's a clever way to reduce overhead. Any other tips for optimizing cookies?
The guide also suggests considering cookie rotation, especially for really long sessions.
Okay.
That way, you can prevent cookies from becoming bloated with stale or unnecessary data over time. And for any data that's not super sensitive, stuff that doesn't need to be sent with every single request, they recommend using local storage instead of cookies.
Okay.
And finally, they really stress the importance of monitoring your website's performance. That includes keeping an eye on the size of your cookies and how they're impacting your request headers.
It sounds like managing cookies effectively isn't just about getting the functionality right and the security tight, but also making sure the website loads quickly and provides a smooth experience for everyone. Now, the guide also touches on the developer experience when working with cookies, and it sounds like it's not always smooth sailing, particularly with the recent push for tighter security and privacy.
You could say that. While the increased emphasis on security and privacy is a great thing for users, it has definitely made things a little more complex for developers.
Okay.
The same site attribute is a good example. While it's a big step forward for security, it's created some debugging headaches for developers, especially when they're trying to get older websites up to speed with these new, stricter settings.
Right.
And getting things to work consistently across all the different web browsers, especially with embedded content like iframes, that's been a real challenge too.
Yeah, the guide mentions that even with the same site none setting, browsers like Brave and Safari can be a bit picky with iframes.
Yeah.
And the storage access API is a possible workaround, but not a perfect one. Sounds like figuring out those browser-specific quirks can be a real pain.
It can be, for sure. Developers have also been pretty vocal about their frustrations with cookie consent banners.
Yeah, those things.
They understand the need for regulations like GDPR, but a lot of them feel like the way consent is implemented on a lot of websites right now, it's not the best user experience, and it doesn't necessarily give users real control over their data.
Right.
There's a lot of discussion going on in the development community about finding more elegant and user-friendly ways to handle consent.
Interesting. And the guide also points out that there are ongoing debates about the best ways to securely store JWTs, those JSON web tokens we talked about.
Absolutely.
While using cookies with those security flags we discussed is common, developers are always looking for extra ways to protect against things like XSS attacks.
Exactly.
Sounds like best practices in this area are constantly evolving.
Yeah, web development is a fast-moving field.
That's for sure.
The best ways to handle authentication and user sessions are always being refined as new threats pop up and browser technologies keep moving forward.
Which brings us to the future of cookies.
Right.
The guide points to some pretty big trends on the horizon.
It does.
Major browsers are phasing out third-party cookies. Browsers are adding more and more privacy-focused features. And there are new standards for cross-site authentication being developed. It really feels like we're on the cusp of some major changes in how the web handles user data.
Oh, absolutely. The focus on user privacy, it's really reshaping how we use cookies, especially those used for tracking what you do across different websites.
Right.
While first-party cookies are likely to remain a key technology for managing sessions and personalization within a single site, the whole world of third-party tracking is undergoing a major transformation.
So to sum it all up, it sounds like even with all the challenges and the emergence of these newer technologies, cookies are still a vital part of how the web works.
I think so.
Understanding how they work, how to keep them secure, and when you might need to use something else, it's essential knowledge for anyone who builds websites or even just uses the internet.
Absolutely. Like the guide concludes, being informed about how to use cookies properly, the security implications, and what the alternatives are, that empowers developers and users alike to make better decisions about how they interact with the web.
And for anyone who really wants to get into the nitty-gritty, the technical details, the guide recommends a couple of great resources.
It does.
There's the MDN web docs on HTTP cookies and RFC 6065, which is the official technical spec for HTTP state management.
Those are the go-to resources for anyone who wants to understand exactly how cookies work under the hood.
So here's something to ponder as we wrap up. As browsers continue to prioritize user privacy and move away from third-party tracking, how will websites find that balance between offering personalized experiences and respecting these new privacy boundaries?
Right.
What new innovative solutions will we see that go beyond traditional cookies to create engaging and personalized online experiences in a world where privacy comes first? It's definitely something to keep an eye on.
Definitely.
Thanks for joining us on this deep dive, everyone.